So this is the randomized safety data that are arranged according to location 1, location 2, location 3, and location 4. The formula of mean, variance, and standard deviation is used. Hence, the overall mean of BOD is this value, variance, and standard deviation. So this is the overall mean, variance, and standard deviation of DOC, and overall mean, variance, and standard deviation of SFS. So this is the mean, variance, and standard deviation of BOD for location 1. So this is the mean, variance, standard deviation of DOC for location 1, and this is for SFS for location 1. By using Microsoft Excel, I have calculated a skewness which is negative 0.09504, which falls into this category. Hence, the data distribution is fairly symmetrical. Mean is approximately to median and mode. So this is the mean, variance, standard deviation of BOD for location 2. This is the mean, variance, standard deviation of DOC for location 2, and this is the mean, variance, standard deviation of SFS for location 2. The skewness of BOD of location 2 is 0.823021. Hence, the data distribution is positively skewed. Mode is smaller than median is smaller than mean. This is the mean, variance, and standard deviation of BOD for location 3. So this is the mean of DOC, variance, standard deviation of DOC, and this is the mean, variance, standard deviation of SFS for location 3. The skewness of BOD of location 3 is negative 0.26554. Hence, the data distribution is fairly symmetrical. Mean is approximately to median and is approximately to mean. This is the mean, variance, standard deviation of BOD for location 4. So this is the mean, variance, standard deviation of DOC, and mean, variance, and standard deviation of SFS. The skewness of BOD of location 4 is negative 0.01704. Hence, the data distribution is very symmetrical. Mean is approximately to median, approximately to mode. According to this bar chart, mean of DOC for location 2 is greater than location 3, location 1, and location 4. Hence, location 2 has the highest DOC, while location 4 has the lowest DOC. Next, comparison of mean of SFS for all 4 locations. According to the bar chart, location 1 has the highest SFS, while location 3 has the lowest SFS. Comparison of mean of BOD for all 4 locations. According to the bar chart, location 3 has the highest BOD, while location 2 has the lowest BOD. Hence, location 3 water sample is the most polluted, while location 2 water sample is the least polluted. We see that the standard deviation of location 4 is the highest, while location 3 is the lowest. Hence, location 4 is the most spread out with higher range of BOD values, while value of BOD in location 3 is the least spread out with smaller range of BOD values.
For second question, test at 5 significance level if there is a difference on DOC reading between location of water sources. Write the ANOVA model and its assumption. Firstly, we separate DOC value from data according the different location, which are location 1, 2, 3, 4. Next, for hypothesis imaging, we have one factor with 4 levels, so H null is at all levels are equal to one another. For H1, mean I not equal mean J, but not all means are not equal at least one. After analysis data, we know F value is 2.33391 with F critical is 2.806x45. We conclude we unable to reject H null at level of significance 0.05 since the calculated F is 2.33 is less than the critical value of 2.81. From sample, we conclude there is no significance difference on DOC reading between location of water sources. For ANOVA model is Yij equal mut I plus random error Ij. For assumption, we consider random error Ij is independent normal distributors with 0 sigma square.
I'm Chi. Now I'm going to answer the question B3. B3 is asking to apply the linear regression for BOD and SFS. The first thing we are going to do is we need to determine which is independent variable X and dependent variable Y. Since SFS is the factor which contribute to the BOD reading, thus we can say that Y is BOD and X is SFS. This is the summary output that obtained from Excel. The number that I highlighted will be used later. This is the line fit plot also obtained from Excel. We can see that the point is scattered in different directions. Thus, we can conclude that there is no relationship between BOD and SFS value. For question B31, the question is asked to fit a linear regression model relate BOD and SFS. We had learned before, linear regression model is y hat equal to alpha hat plus beta hat x. Thus, my answer is y hat equal to 1.5096 plus 1.6334 times 10 power of negative 4x. For question B32, the question is asked to test the linearity between BOD and SFS at 1% significant level. So, to test the linearity, we need to proceed with testing the hypothesis. For this question, we set the h0 is beta equal to 0 and h1 is beta no equal to 0. We will reject h0 if significant f is smaller than alpha. The conclusion we make is unable to reject h0 since significant f is greater than alpha. From sample, we can conclude that the BOD and SFS has no linear relationship. The question is also asking to comment the R value. The R value that we obtain from data is 0.0140. Since R value is close to 0, thus there is little or no relationship between BOD and SFS. From the answer above, we can make a conclusion for B3, which is SFS value will not affect the BOD reading.
Hi, I'm Shin. And now I'll be discussing on question B4. Based on this question, we are required to perform a goodness of fit test at alpha equals to 0.05. So the first step, we need to list down the H null and H alternative. The H null is equals to the BOD reading generated follow the normal distribution with mean 1.5 and variance 0.135. And the H alternative is the BOD reading does not follow the normal distribution. Then, I had divided the 50 data generated into 15 different groups with range of 0.05 each. Then, we can proceed to calculate the probability by using normal distribution. Here is the example for x ranging from 1.2 to 1.25, and the probability is equals to 0.0422. Then, we can use the probability to calculate the value of EI. EI is equals to the probability of I times number of sample, which is equals to 50. Here is the example, but in the theorem it is stated that EI should be at least 5. Thus, we need to combine the rows here to make them more than or equals to 5. After combining the rows, we can proceed to calculate OI minus EI squared over EI by substituting OI and EI here into this formula. And here's the example. Then we can calculate the value of chi-square test, which is equals to sum of OI minus EI squared over EI equals to 20.2778. The criteria for this question is to reject H null if chi-square test is more than chi-square alpha, which is equals to 0.05 and n-1 equals to 6. This value, we can get it from the statistical table. We can see that the value of chi-square test is greater than this value. Thus, we can make a conclusion to reject H null. The BOD reading generated does not follow a normal distribution with mean 1.5 and variance 0.135 at alpha equals to 0.05. Thus, we can conclude that this assumption is not true. That's all from me, and thank you.